Dear students, I am S. Ilayaraja, working as Associate Professor in Velamal Institute of Technology. Today is a good day as you are going to learn the control system, the Unit 1. So here the Unit 1 control system modeling, the objective of this unit, the students can able to understand the following topics: the basic elements of control system, open loop and closed loop control system, transfer function, modeling of electric system, and translational and rotational mechanical system. After learning these topics, the student can able to perform or model electric system for the mechanical system. So this is the outcome of this course. So let's see what is control system. A control system is a combination of elements arranged in a planned manner wherein each element causes an effect to produce a desired output. So a control system is a combination of subsystems which is arranged in a planned manner wherein each element causes an effect to produce desired output. So you can see the simple diagram. You are giving an input to a system, control system, then based on the input the system produces an output which is called the response. So when you are giving input, that is the desired response, that is what you are giving as an input, and the output of the system will give you that actual response. So it's a figure represents a simplified description of a control system. Transfer function. The transfer function of a control system is defined as the ratio of Laplace transform of output variable to the Laplace transform of input variable by assuming all initial conditions are 0. Therefore, the transfer function equal to C of S by R of S. So a simple block diagram shows the input R of S, output C of S, and the transfer function G of S. And the classification of control system. So we have two types in classification of control system. One is called open loop system, another one is closed loop system. So open loop, it has an input and you have an output. There won't be any feedback in open loop. So the output depends on the quality of input, but the input never depends on the output. But in a closed loop system, you can see the input and it is converted using a transducer, then it is given to a controller, then process, then you are getting output, and a partial of the output is feedback to the input, and error signal is generated, and based on the error signal the controller starts works. So this is what if the input depends on the output, then it is a closed loop control system. So we have a definition of open loop and closed loop control system. A system in which output is dependent on the input but input is totally independent of output or changes in output of the system. The closed loop system, a system whose input is dependent on the output or changes in output. That is, such system uses feedback, which is called closed loop system. So we have a comparison of open loop and closed loop system. In open loop, accuracy depends on the calibration of input, but in closed loop, more accuracy because the error between the reference input and output is continuously measured through feedback. The second advantage, the comparison, is simple to construct and cheap open loop system, but closed loop system is complicated to construct and it is costly. The third comparison, in general the open loop system is stable and closed loop system it become unstable under certain conditions, and it is open loop system, it is affected due to the presence of non-linearities present in its elements. In closed loop system, it adjusts the effect of non-linearity present in its element because of the feedback. So you have a open loop and closed loop system. You can see in open loop you are giving input that is given to a controller, and disturbances, which is called the non-linearities or any noises, will be added along with the input that will be taken in the output. But whenever the disturbances enters and the non-linearities due to the elements which is not removed in the output, which is also processed through the plant. But when you come to the closed loop system, whenever an error signal occurs or a disturbance occurs, that will be measured through the feedback, and again it is given to the compared with the input. So error signal is the actuating signal given to the controller, and the controller will start work on the error till the output reaches the desired one. So these are the two basic classification in system, control system, open loop and closed loop system. And let's see how to find a transfer function of a simple electric circuits, RL circuit. You can solve this problem by writing KVL at the input, the applied voltage in terms of Laplace transform V of s equal to R plus SL into I of s. And you are taking output across the inductance, so load voltage VLS, which is equal to LS into I of s. So the transfer function is VL of s by V of s, which is called LS by R plus SL. The same way we can able to find the RC circuit transfer function. So by applying KVL, the equation V of s equal to R plus 1 by Cs into I of s, and the voltage across capacitor can be in terms of Laplace Vc of s equal to 1 by Cs I of s. By taking the ratio of Vc of s by V of s, we will get the transfer function. So when you simplify this 1 by Cs by R plus 1 by Cs, you will get 1 by 1 plus RCS. So this is a 2-mark question which will be asked in your exam. Find the transfer function of RL circuit, RC circuit, similarly a RLC circuit. So here an RLC circuit which is connected in series, applied voltage V of t, RLC, the current flowing through the circuit is I of t. You can solve this problem in two ways. One is by applying KVL, you will get V of t equal to RI of t plus L di by dt plus 1 by C integral I of t. By taking Laplace transform, you will get it is V of s equal to I of s into R plus SL plus 1 by Cs. And output is taken across capacitor. So by writing KVL, Vc of t equal to 1 by C integral I of t, and in Laplace transform 1 by Cs I of s. So the transfer function is Vc of s by V of s, which is nothing but 1 by Sc by R plus SL plus 1 by Sc into. When you take LCM of Sc, you will get this transfer function. So you can also solve this problem by using voltage division rule, which you have studied in your circuit theory. The same value divided by sum of the entire resistance value. But here it is in terms of RLC, so we consider it as impedance. Impedance of capacitance divided by sum of impedances RLC. So you will get here into VI of S. So it is also a 2-mark question which will be asked in exam. Find the transfer function of an electrical circuit shown in figure. Then next we are going to see the translational mechanical system and rotational mechanical system. The classification of mechanical system classified based on the translational and rotational. So what are the basic components which used in translational? One is spring, another one is viscous damper, and the third one is mass. And the force is applied to the mass, and due to the force there will be a displacement takes place in mass, which is represented by x of t, and here the viscous damper is represented either B or Fv is the notation. When the force applied, there will be a displacement takes place in viscous damper. The same way there is a force applied in the spring, there is a displacement will takes place, that is represented by x of t. So the basic components of translationals are mass, damper, spring, force, and displacement. So when you write the force velocity equation, it is F equal to K integral V of t dt, and in viscous damper F equal to B into V of t, and in mass F equal to m dV by dt. When you write this equation in terms of displacement, force and displacement, F equal to Kx, F equal to B dx by dt, F equal to m d square x by dt square. Here it is x. And when you come for the rotational mechanical system, the same, the components of rotational mechanical systems are same: spring, viscous damper, and instead of mass, here it is an inertia. So what is the torque? The torque is applied, and the angular moment represented by W. Here displacement in rotational, it is angular moment or theta displacement. So when you write torque versus angular velocity, T equal to K integral W, T equal to BW, T equal to J dW by dt. And in terms of torque angle displacement, T equal to K theta, T equal to B d theta by dt, T equal to J d square theta by dt square. Since we know that W is nothing but d theta by dt. Similarly, velocity is nothing but dx by dt. So this basic components which is used in the modeling of control system using an electrical circuit. The next one, the transfer function of translational mechanical system. You have a damper, spring, and mass, and the force is acting here. So by Newton's second law of translational motion, we can write F equal to m d square x by dt square plus f dx by dt plus k x of t. Now take Laplace transform on both sides. F of s equal to ms square x of s plus fes x of s plus k x of s, and f of s equal to ms square plus fvs plus k into x of s, and the transfer function can be written as 1 by ms square plus fvs plus k. Similarly, we can write the transfer function for rotational mechanical system, and the spring, damper, and inertia. You can see these two comparison. So the comparison here is, here force is applied, here torque is applied, and here displacement, here angular moment. So when you write by Newton's law, T equal to J dW by dt plus FEW plus K integral W. So we know W as d theta by dt. When you substitute this, you will get J d square theta by dt square plus Fe d theta by dt plus K theta. Take Laplace transform on both sides, you will get ms square plus theta s plus fes theta s plus k theta s, and your transfer function will become 1 by j square plus fes plus k. So you can compare the transfer function of translational mechanical system and rotational mechanical system. Both are same, only thing here mass and here it is inertia. And now how we can convert this translational and rotational in terms of electrical components. So we must know the basic of passive components. The passive components are resistor, capacitor, inductor, and the Laplace transform of these basic passive components are R. Capacitor means it is 1 by Cs, for inductor it is SL, and for mesh analysis we can able to write the voltage to current relation and voltage to charge. So V equal to IR for resistor, V equal to 1 by C integral I dt, V equal to L di by dt. And we know that current is nothing but it is dq by dt. So by substituting the current is a flow of charge, then you will get voltage to charge relation. So dq by dt into R, 1 by C into Q, and L d square Q by dt square. Similarly, for a nodal analysis, we can able to write the relation between current to voltage. So current equal to voltage by resistance, and current I equal to C dV by dt for capacitor, and current I equal to 1 by L integral V dt. So here is it's a mistake, L. So And similarly, we know that the voltage is nothing but the rate of change of flux. So V equal to d phi by dt. By substituting that, you can get a relation between I to flux. So 1 by R d phi by dt, C d square phi by dt square, and 1 by C phi. So these basics you have to remember so that we can compare the translational and rotational mechanical system with the basic electric circuits. So next we are going to see the force voltage and force current analogy. You have a translational mechanical system. This mechanical system is equivalently converted into a series circuit, RLC series circuit, RLC parallel circuit, which is called force voltage analogy, force current analogy. So the translational mechanical system will have mass, damper, spring, force, displacement that will be changed into a electric circuit with what is the equivalent values. So by Newton's law, we have written f of t equal to m d square x by dt square plus b dx by dt plus k x of t. Similarly, for a RLC series circuit by KVL, we can able to write applied voltage equal to R into I of t plus L di by dt plus 1 by C integral I of t, and substitute I equal to dq by dt, you will get L d square q by dt square plus R dq by dt plus 1 by C q. Now compare these two equations. You can able to obtain a relationship between the translational mechanical and force voltage. The force F of t, which is equal to the voltage, the mass m, which is equal to the inductance, the viscous damper B, which is equal to resistance, and the spring K, which is equal to 1 by C, and the displacement X, which is equal to Q charge. So this is the force voltage analogy equivalent parameters which is obtained for a mechanical system into an electrical system. Now when you go for a force current analogy and it is a parallel RLC circuit, by writing KCL you will get I of t equal to 1 by R E of t plus C dE by dt plus 1 by L integral E dt. We know that voltage is d phi by dt. By substituting that, you will get it is C d square phi by dt square plus 1 by R d phi by dt plus 1 by L phi. Now compare the first equation and this current equation. You will get a force current analogy parameters. The force equal to current and mass equal to capacitance and damper equal to 1 by resistance and spring equal to 1 by inductance and displacement equal to flux. So you remember these two box which shows you the force voltage analogy and force current analogy which is used in solving problems. So by using these parameters, you can able to model any mechanical system, translational mechanical system into its equivalent electrical circuits. Then the next one is rotational mechanical system. For a rotational mechanical system, how we are going to develop a torque voltage analogy and torque current analogy. So in rotational, we know that instead of force we are using torque, and instead of mass we are using moment of inertia J, and instead of displacement here it is angular movement. Therefore by Newton's law we can able to write the torque equal to J dW by dt plus bW plus K integral W. And when you write a KVL to this RLC series circuit, we can able to write L di by dt plus Ri plus 1 by C integral I. By comparing these two equations, the torque equal to voltage, inertia equal to inductance, damper which is equal to resistance, spring equal to 1 by capacitor, and the W which is nothing but I of t. And similarly, by writing a KCL equation for this torque current analogy, you can write I of t equal to C dE by dt plus 1 by R E of t plus 1 by L integral E dt. You will get, compare the first equation and the third equation, you can able to get the torque current analogy T of t which is equal to I of t, and inertia which is equal to capacitance, and damper which is equal to 1 by R, and spring which is equal to 1 by L. So from these two equations you will come to a conclusion. You just see here, if you apply duality of this torque voltage analogy, you will get torque current analogy. So what is duality? Duality means voltage is current, inductance is capacitance, resistance is 1 by R conductance, and 1 by C 1 by L. Okay, and current, which is equal to voltage. So if you apply a duality of torque voltage analogy, you will get torque current analogy. Similarly, if you apply a duality to force voltage analogy, you will get force current analogy, and the series circuit become parallel circuit, and f of t, v of t, here f of t, I of t, and L become capacitance, R become 1 by R, 1 by C become 1 by L, x equal to Q equal to phi. So by using this, we can able to solve problem. So let's see a simple, this is a summary of this development of force voltage analogy, equivalent mechanical system that is converted into a electrical circuit, and what is the parameter in terms of L is M, resistance is damper, and capacitance equal to 1 by K. Similarly, we have a development of parallel analogy, which is force current. So a parallel circuit is shown here, and the relationship is also shown here.